Building cabinets, a project by group executives. Background: operating complex systems require control cabinets. A complex system can be a crane, a machine for making cheese, a ship, a house, and many others. Usually, machine or system builders try to use standard enclosures because of the price advantage and available ready solutions. This is logical and works well in most cases. Big manufacturers have almost fully automated lines to produce standard enclosures, and they utilize economies of scale. For that reason, they're not interested in producing lower volumes of non-standard solutions. This opens a niche for smaller scale manufacturers, where the solution depends on the imagination of the customer's design department. This is the case with the enclosure we plan to build in a small manufacturing facility. This enclosure is meant to be used as a part of the control system for purification of ballast water. Such systems are needed to prevent biological contamination when ships travel through different oceans and seas. Since this solution is meant for seaworthy usage, it means that it requires rigidness to withstand the rocking of the ships and also good anti-corrosion protection. How do we plan to produce these enclosures? We start with defining the necessary resources. The first thing to do is to define the operations, material, and operations flow required to make the product. Total costs. The overhead rate is about 14 leva and the total cost 1,600. The biggest portion of the cost comes from the subcontracting operations and the material. The know-how in building the enclosure is related to the welding and grinding processes, which will be executed by our company. To achieve the production rates, it's important that the processes are organized efficiently. The machine operations include laser cutting, punch press, bending, and powder coating. These activities are handled by subcontractors. The subcontracting operations are related to mostly machine-intensive processes. These are standard machines, and there are lots of companies that can provide these services. Laser cutting. The cost per piece is 49.5 leva. The total cost for 1,000 units is 49,000 leva. Punch press. The cost per piece is 170 leva and the total cost is 170,000 leva for 1,000 units. Bending. The cost per piece is 109 and the total cost is 110,000 leva. Powder coating. The cost per piece is 400 and the total cost is 400,000 leva. The labor operations include welding, stud welding, and grinding. Welding. For 1,000 units, we need about 6,000 hours. 4 people. With a total cost of 64,000 leva. Stud welding. For 1,000 units, we need 533 hours, with a total cost of about 5,000 leva. Last but not least, it's grinding. For 1,000 units, we need 4,000 hours. 3 people, with a total cost of more than 37,000 leva. To produce 1,000 units, we need to spend more than 10,000 hours for a total cost of more than 100,000 leva. The total direct material cost for 1,000 items is about 570,000 leva. In order to produce an enclosure, you need the following ingredients: sheet metal, fasteners, welding and grinding consumables and paint. Using suppliers with high-quality products is vital for the quality of the final product. Overhead. The overhead includes rent and utilities, truck, vehicle depreciation, welding machine, angle grinder, project manager, foreman, and warehouse admin. The total overhead for the year is 150,000 leva. The cost for the rent includes utilities as well. A truck will be needed to transport the products between our factory and the subcontractor. The job of the foreman is to organize the production process and to ensure that all procedures will be followed. This will secure that the quality of the product will be stable and that the schedule is completed on time. Operations flow. The first step of the operations flow is the order. The project management department handles the order flow and the communication with the customer. Then it comes the material inspection. The warehouse department checks the quality of the incoming material according to the ISO standards. Then the warehouse department arranges transportation of the raw material to the subcontractor. The subcontractor is responsible for punching, laser cutting and bending. Next step is welding bolts, done by the welding and grinding department. The welding and grinding department is responsible for grinding. Then the quality control department inspects the enclosure. If it doesn't pass the check, then the process goes back to the previous step. However, if it passes the check, then the assembly department packs the enclosure in pallets. Then the subcontractor dispatches for painting and assembly. Once the painting and the assembly is done, the warehouse department dispatches the painted enclosures to the customer. The production process doesn't include separate settings and/or fittings per batch or per item. The most appropriate method in our case is the traditional direct labor hour-based absorption of overheads. Thus, we would calculate all of the overheads and divide by the total activity. Break-even point. An alternative to our product is manufactured by Eldon, and the selling price is £772, equal to 1,675 leva. This solution is standard. It doesn't include many of the internally welded components. It doesn't include painting inside, and it's not constructed for seismic resistance. Since our product is not a standard solution and it requires more labor, and given the fact that production is in a low-cost country, the markup is 35%, which results in a profit margin of 26%. The price is competitive when complexity is taken into consideration. The operating leverage shows that the profit is relatively dependent on the volumes. The margin of safety is calculated based on the projected sales for the first year, and it shows that they are well above the break-even point. Budget. Cash is collected from sales in the following month. Employees are paid in full in the current month. Sales and admin are paid in the next month. Rent is paid in full in the quarter. 30% of next month's orders is in inventory. 30% of the needed material for next month is in inventory. Subcontractor is paid in the following month. All direct material is paid in the same month. Truck, angle grinder and welding equipment is purchased in quarter 1. In year 1, the sales are estimated to 500 units, the price to 2,133 and the sales value to 1,066,922. The cash collection from sales in Q1, 2, 3 and 4 has been estimated to 1,013,576. The cash disbursements for direct labor are estimated to 56,710, for overhead to 133,800, for direct material to 320,612. The total disbursements for year 1 are 1,057,549. We have estimated that the total cash would increase steadily over the next years with a slight drop in the fifth year. The total disbursements would slightly increase until year 3 and then the trend would go down. The cash surplus would significantly rise in the next 5 years. During the first year, a bank loan will be needed to secure the necessary cash to start the business. This will be a 5-year loan with 6% interest rate. In the first quarter of operations, the company needs to acquire the proper equipment, which will be used for production. The first 2 months are expected to be a ramp-up period. After the third year, the loan can be paid back in full. Income statement. Operating profit margin is similar to one of the big companies producing enclosures. Financial cost is the total interest divided by 20 quarters and then multiplied by the number of quarters in the year. The assumption is that we will start paying back the loan from the second quarter of year 1. The expected profits will grow as the business develops. Net present value. The net present value is more than 800,000. This is a good indicator because the figure is positive. The internal rate of return is 97%, which is higher than the discount rate. The figures show that investing in this business is a smart decision. The net present value and the internal rate of return are extremely good and the payback period is short.